Okay, here's a problem from class today. We had the y equal x to the 2/3. We found the arc length from 0 to 3, took the derivative, wrote it algebraically because it was easier to see, and then plugged it into the arc length integral formula. So we get the arc length s is equal to this. Okay, then we went and did it. Now, I'm going to do it a different way, or a second way, and the key is that in x world or y world, y equal x to the 2/3 has the same arc length. So what this says basically is that if I solve for x, I can do this as a y world arc length. So basically, here's what I'm going to do. I'm going to solve for x, and I get y equal x to the 2/3, raise each side to the 3/2. So I get y to the 3/2 equaling x, which is going to be some function of y. Okay, so now what I'm saying here is that this arc length right here is the same no matter whether I use this one or this equation. The only difference is that I have to use the y coordinates. So I have to go from this y to this y. So in other words, I can do this. I can say, okay, I'm going to go from y0 equaling 0, because that's the y coordinate at that point, to 3 2/3 equaling y. And I'm going to get the same arc length. So what do I have to do? Well, I have dy here, and then instead of y prime equal, I'll use x prime equal. So I look for x prime. X prime is 3/2 y to the 1/2. So I have that. Well, this becomes 0, 3 to the 2/3, 1 plus this quantity squared. With respect to dy, sorry, I don't mean to crowd things down here, and this becomes this integral. And this should look familiar because we did this in class in the x world. So I'm going to go continue this on the next page, but I just want to show you the basic idea. This arc length, we can do it as an x world arc length or a y world arc length, and we get the same exact answer. What we have to do is we have to solve for x, which we did here, and then we have to change the limits of integration. So I'll continue this on the next page. So I'm just going to copy it over. 0, 3 to the 2/3, 1 plus 9th for y dy, and in class we did this one. I think we had different numbers. I can't remember, but I think it was this. Okay, so it's the same integral, so I might as well do it again. U is 1 plus 9/4 y. Du is 9 over 4 dy. 4/9 du is dy. It's supposed to be a 4. So this integral now becomes y equals 3 to the 2/3, 0. U to the 1/2 for what's inside here. That's my u. Instead of d, this is supposed to be a dy here. Dy becomes du 4/9. And I'm going to write this as a u. U2 is going to be 1 plus 4/9 y. And then u1 is going to be 1 plus 9/4 0, which is just 1. So I'm going to integrate with respect to that. I did something like that in class today. So I integrate this, and I get, I'll do it over here, 4/9 u to the 3/2 over 3/2 and 1. That's my u2, and that's my u1. Okay, well, clean that up, 2/3. That's going to be 8/27. Now I plug in 1 plus 9/4 times 3 to the 2/3, quantity 3/2, minus this one over here, 1 plus 0. I'm sorry, u1 is 1, so it's just 1 to the 3/2. And then I can just leave it like this. I'll clean it up a little bit. Again, it's a nice trick. So what I'm suggesting here is that if you look at a function and you can think ahead like this and say, oh, that's much easier to find the arc length of than this, by all means do so. Switch it into the y world. Solve for x and use this version of the formula. I did that, and this is what I got. And again, if you want to check this, again, compare to this one that we did in class. It's the same idea. Anyway, thank you. Thanks a lot. Bye-bye.